Shabana KM, a PhD scholar in the Department of Computer Science and Engineering at Indian Institute of Technology, Palakkad. I have a 5-year-old son who is studying in UKG, also known as KG2. The other day, while I was helping him with his school homework, I noticed that since the past many days, he was doing the same math homework, writing numbers from 1 to 50, which he was already proficient in by that time.
And this was our expression when we saw the same homework again.
And then my son told me how one of his friends in school still got the numbers wrong and how the teacher was slightly annoyed at that boy. When he recounted this incident to me, I was once again reminded about one of the pressing issues with both the traditional classroom as well as the MOOC setting, which is the one-size-fits-all approach where the same lessons in a fixed order are delivered to all the students irrespective of their individual learning characteristics. A one-on-one human tutor can definitely help overcome this problem by providing personalized instruction based on the individual learning requirements of each student. However, we know that it is difficult to scale one-on-one human tutoring to a large student population because of the cost factor involved as well as the shortage of sufficient number of well-trained tutors.
And that brings us to my research topic, how to scale personalized education using artificial intelligence. Specifically, how to design intelligent tutors that provide lessons or exercises that cater to the individual learning requirements of each student.
Now let's consider how this can be done in the context of teaching students a set of math concepts where students learn concepts by solving problems. First, let's see how a human tutor might approach this task by going back to my son's story. After learning numbers from 1 to 50, what are the other possible topics that he can learn?
Numbers from 51 to 100, before, after, between, what comes next in a sequence, matching shapes. Now which one to select? One way is to provide him with activities from each of the topics and observe which topic he tends to learn quickly and provide more questions based on that topic. Now, once I identify the topic that he is learning the fastest, I can provide him with more activities from that topic until he achieves mastery. But there are two important problems here. Firstly, how to find the right topic for my son without wasting a lot of questions on the other topics. Now, this right topic may differ from one student to another. Secondly, how to determine when my son has mastered a topic. This will help to provide the right amount of practice to a student.
A human tutor might be able to perform these tasks based on his or her experience and formal training. But how can we build an intelligent tutor to solve these problems automatically?
Now, coming to the first task. When there are multiple concepts that can be taught to a student, how to find the topic that the student learns the fastest? This is done using a machine learning technique called multi-arm bandit. Even though the name sounds sophisticated, it is a very simple technique. You can think of a slot machine with multiple arms. When you pull each arm, you get a reward. The objective of a bandit algorithm is to find the arm that gives higher reward using a minimal number of arm pulls. Now consider the tutoring setting. Here the concepts or topics form the arms of the slot machine. The rewards are the student performance measures, such as the correctness of student answers to a question related to that topic. Now the bandit algorithm will explore various arms and find the arm or topic that gives higher rewards, that is, better student performance in our case, by using a minimal number of questions. Next, let's look at the second problem of how to determine if the student has mastered a topic. Given below are the sequence of correctness of student responses to questions related to a topic. Which sequence do you think corresponds to that of a student who has mastered the topic? Sequence 2, right? Why? Because student 2 has mostly given correct answers to the recent questions, while this is not true for student 1. This is the intuition behind the technique used by the AI tutor to determine if a student has mastered a concept. It looks at the recent sequence of correctness of student responses and checks if it resembles that of a student who has mastered the concept.
In this way, AI techniques find great applications in the design and development of intelligent tutoring systems. I find this a very exciting research area that can positively impact the quality of education delivered to students worldwide.